talking about what they mean, but that's super important in this chapter. First thing I want to talk about is independent and dependent events. So, independent events means if I tell you one thing, like, what's the probability that you're going to pass the AP test? You can think of that probability in your head and be different for every person. If I just say probability of you pass the AP test, you can put a number in your head, whether it's 100%, whether it's 0%, whatever it is. Now, if I tell you a second piece of information, if that piece of information changes the probability that's in your head, that's dependent. That means those two things are related. If the piece of information I tell you does not change that probability, that means the two things are independent. They have nothing to do with each other. So put that percentage in your head. What percentage chance do you think you have to pass the AP test? You have to say out loud. Just keep it in your brain. Now this new piece of information is you got an A second semester. Does that change your answer to the first question? Some of you might not, actually. If it did, those would be dependent events. If it didn't, those are independent. But keep that probability in mind. Probability in mind. My dog pooped in my upstairs carpet this morning. That changed? No, that wasn't just a story. That actually happened. But did that change your probability of passing the AP test? So are those two things independent or dependent? Okay. Go back to that. Keep that. What'd you say?
I said the wrong thing.
You good?
Yeah.
Okay. Keep that original probability there. Now my new piece of information is you guys get to take the AP test in partners. Did that change probability?
Yeah.
Independent or dependent? Dependent. Go back to that original probability. Now my new piece of information is the AP test is the same amount of questions, but it's only 30 minutes long. Did that change probability?
Yes.
So independent or dependent? Dependent. Think about probability that you do your homework today.
We're doing it this time. We are all
100%.
doing it this time.
So,
What's our homework? If I'm doing it, you're
I don't think you're going to have homework today. But just pretend you. So, pretend we have homework. Think about the probability you're going to do it. Now I say, if you do it, I'll give you 30 extra credit points. Independent or dependent? Dependent. Now I say, my dog crashed my house. Independent or dependent? What? Not really the point we're trying to get to. So those are independent, right? Although, can anybody make an argument that if my dog poops in my house, it does change the probability that you do homework? Yeah, so you could, like, sometimes people are like, no two things are really independent because I can, like, connect them. Like, someone last year, I could not get them out of it. He was like, no matter what you say, I can connect them. So, like, the dog in the house, he's like, yeah, well, that pissed you off. Then you're mad at class, so you yelled at him, so people were scared of you. If that is true, is that dependent or independent? That would be dependent if you follow through, like, all those chains of events. Michigan plays Ohio State Saturday. Think about the probability they're going to win. They're not going to win. Would that probability change if I told you I mowed my grass yesterday?
Well.
No.
Can anybody connect that? How?
You mow your grass, right? It's like the leaf, the grass blade. It's like, corn sucks, right? So he throws a ball, it's like, hell right, okay? But like, every piece of grass hits the ball, goes up just a little bit.
Wow, he did it.
Okay,
I got
this is
one.
exactly what Donovan did last year, yeah.
Okay, so you were mowing your grass, but a blade of your mower flung out,
He was on the same
cut
story.
someone's leg, cut his running back's leg, so he's injured. Then someone
He got hurt by the blade of grass.
Yeah, no, your mower, like the metal.
It flew like 30 miles.
No, they were driving by because they were saying Michigan sucks. And then, like,
They were driving through my neighborhood.
yeah, like they were yanking down
With
Michigan
their legs
flags.
sticking out of the car?
Yeah, I drive like that. She does.
Oh, no, they have the Jeeps. So you can like.
Yeah, they're driving through your middle class saloon.
Yes. Yanking down Michigan flags, and then your plane leaks out, gets in their legs.
See, so this one, like, if you go that far, you can almost argue anything, but does it make sense? sense the idea I'm trying to get across?
Yeah.
Independent is that one event has no effect on the other, and dependent is if one event changes the probability of the other. So let me try this then. Me flipping a coin and getting heads, and me flipping the same coin and getting tails. Are those independent or dependent? Why?
Because if you're,
So here, can I do it? Sorry.
yeah.
Everybody in your head, what's the probability that we flip a coin and get heads? Think of it in your head. Now, this second piece of information, your job is to tell me if that changes the probability that's in your head. The second piece of information is I flipped that coin and got tails. Does that change probability that we just got heads? It's one flip. It's not like back to back to back. So on one flip, I can either get heads or tails. Before we flip anything, what's the probability I get heads? 50%, right? Well, now the new piece of information is I flipped it, I got tails. Now what's the probability that that flip that already happened, we get heads? 0. Because I just told you we got tails. Gender. What's the probability that a person is born male? 25.
No, I forgot to go. Yo, that's your color. Just kidding. You're so stupid.
Only one thing has to change.
So do you think 75% of the people in the world are women?
Well,
Yeah.
every guy is half a girl. They just have a Y. Or an X. I don't know which one.
It's like harder to watch.
I remember
And
that.
males are more likely to die in the womb.
Females have 2 X chromosomes or something.
Yeah,
They are.
males
I
have an
get
X.
that, but you guys realize the world's like half male, half female,
No, there's
right?
more
Every
females.
male is half female.
What?
The chromosome into a male.
No.
I think it gets to
So
that
you
point.
have X and X.
That's not what
So
I'm-
you're half girl.
You know, half the people in the world have penises. How about that?
The Y chromosome is dominant, and that's why.
Why are we talking about chromosomes?
Because you said that you were
Talking about probability.
I'm not talking about the probability of the chromosomes. I'm talking about the... Wow, that was...
All these feminists in here.
Beautiful stuff that's recorded.
I mean, I'm a feminist. I don't think 75% of that has nothing to do with it.
That's how better out.
Yeah.
Never helped your
Alright, so I kind of just listed these out here. Just a couple more examples. So independent means one event doesn't change the probability of the other event happening. Alright, look at this one. At the beginning of the year, you get your schedule, right? And before you come in, you're like, I'm hoping I have, stats is either 4th hour or 5th hour. You're like, I'm hoping I have stats 4th hour. Probability of that's like 50%, right? I mean, probably not, because there's all these other factors, but let's just say it's 50%. Now you get your schedule, you find out you're in 5th hour. Or you find out you're in 4th hour. So, did that change the probability? It did. So, being in 4th hour and being in 5th hour, are they independent or dependent? Dependent. Because if I tell you you're in 4th hour, does that change the probability that you're in 5th hour? Yeah, it makes it 0, right? So I was trying to explain with the male-female thing until we got all the biology. Alright. Completely unrelated, no effect on the other. So for example, probably race today, probably Joe likes granola bars. Joel? You gonna try to connect those somehow? Well, no, but he was just the one that was connected the last one.
Alright, so if it rains,
Oh my gosh.
the humidity goes up, right? And so maybe like if the humidity allows it to smell better. It's like he smells like somebody opened a granola bar.
What?
It does.
Okay.
Or maybe
Okay.
Joe's granola bar
Or maybe
don't
you
suck
dropped it in a puddle.
and then he stops liking it.
Yeah, it doesn't have to make the probability increase, right? Like her thing was maybe now the granola bars are soggy and now he doesn't want it. So it could go either way. It doesn't have to make it better. It could make it worse. In general, do you agree with my idea? Those are pretty unrelated things. Okay. You passing your next chapter test, I did not even know this was the example on here. I must have pooped that day when I wrote the notes too. My dog poops in the house like constantly. It drives me insane.
Oh my god.
So I would argue these are independent. Well, Joel, we could say like dog poops. I'm angry, but I don't think my anger really changes your probability of passing your test. So.
Great. It's hard to make our tests super hard.
Yeah.
True. True. If I'm a fair person, it should be. Yeah. Your ACT score and your shoe size are independent. Unless, like, tall people are smarter or something. Yeah, I said only. So 2 events are dependent. One event does change the probability of the other happening. So owning a home and having an income over $50,000 are dependent, because would you agree that you're more likely to own a home if you make over $50,000 a year than if you don't? So those are dependent events. One thing affects the other. The amount of time that you study and your GPA, in theory, are dependent. So the more you study, your GPA should go up. I don't know if it's always seen that way, but. So once you go through these 10 or 11 at the bottom, and tell me if, just write it down, are they independent or dependent for each one of those? If you know the second thing is true, does that change the probability of the first thing? I would write this on the back if I were you. That's kind of your general thought process that you use. Are you guys' parents coming tonight?
No.
Paula?
He's gonna be Steve.
I'll be at home. I don't remember when she's here.
They'll be in one of the night.
Apparently, yay. I really hope.
Isn't it late tonight?
Yeah.
See, I thought it was tomorrow.
Oh, she always does the dinner, right?
Yeah.
Tomorrow?
Yeah.
Is it dinner?
tomorrow night.
What's she cooking?
Pasta.
Cool.
See, she eats pasta. That big test. That pasta.
Kayla, shut up.
Pasta makes you smarter, is what you're saying?
Yeah.
If you, but I don't know about, you gotta be like in the middle though, right?
Yeah, not
I'm like stuffed, I'd be falling asleep.
No, but like
Yeah.
if you like sugar crash, that's don't drink a lot of
Sugar crash.
Does anybody need this anymore?
No, good.
Okay. You still need it? Okay.
Can you get my dad to go? What do you want?
Is she making you come with her? Do you have to come with her?
I choose to stay at home.
Tiger choose to stay at home? Or her mom just made her?
What did you say?
Tiger always was with her mom. Is that Tiger's choice or her mom's choice?
Because she probably always has something good to say all the time. I don't want to be here.
Oh yeah, he's terrible. I'd be like, yes,
I hate you so
It's not like I'm trying to get back at them. I'm going to be honest. I wouldn't have anything bad to say about most of it. You good? Alright. You passing your test and me wearing yellow shoes. Independent or dependent? Anybody want to try to argue that it's dependent?
No, stop looking at opportunity.
I kind of think it's fun.
Yeah.
Okay, so like if you're wearing yellow shoes, maybe someone gets like more distracted by that. Like for instance, if you're taking a test and you're distracted by your yellow shoes, especially if they're really bright, like highlighter yellow, you can distract them to the point where they forget what they're doing and they can fail the test.
Some Crocs. The guys
Crocs
just.
are pretty distracting. Right.
So independent, but you, like, if you try hard enough, you can get it. Yeah.
So they say like chewing the same gum, you study, it's like will help you.
Oh, really?
You like looking, you like looking at the same color while you study and taking the test.
How can you study if you're looking at the color?
So if I wore yellow shoes while I was teaching and then on the test, that might help.
There's someone highlighted all their notes that they were looking over in yellow highlighter.
Yeah. Alright. Snowing outside and the temperature is above 50 degrees. Dependent or independent? Dependent. If I know it's 50 degrees or higher, does that change the likelihood that it's snowing?
Yes.
Yes. Are you more or less likely to graduate college if we know you graduated high school? Yes, you're more, so that's dependent. Are you more or less likely to pass the AP Stats test because you have a certain brand of phone?
This one's arguable.
I'm going to say independent, but go. Let's hear it. We got
So it's actually been like a pretty common study that iPhone users are generally smarter than Android.
how many people in here are Android users?
Samsung's back.
Seriously, there's like 3?
I used to
4,
be
5?
until my mom
Okay.
smashed it.
She's using iPod now, but no mic.
I'd like to see who designed those studies, but I feel like it was Apple.
Let's make the argument that if you have like a really bad kind of phone,
Like a really cheap one?
like a really cheap one versus like an iPhone, you might spend less
Less
time
time on
on your phone,
it, so
more
you
time.
study more, yeah. Alright. Are you more or less, remember it can go either direction. Shh. Are you more or less likely to pass the AP stats test in May, depending on your grade in this class? Those are dependent, right? You know, if you're failing the class the whole year, that probably means you're not going to pass the AP test. If you get A's all year, probably means you can pass it, anywhere in between. So this is a tricky one for most people. If I know, or does the probability of this coin flip coming up heads change if I know that this coin flip came up tails?
Yeah.
Changes a lot, right? What's your new probability of coming up heads? 0. What was the old probability? 50%. That changed, so that's dependent. How many had dependent? That's the one that tricks most people. Cool. Questions on that? Does your recent grade in the last test make you more or less likely to pass the class? Yeah. Or could it? Yeah, those are dependent. Does the fact that I roll a 4 make it more or less likely that I'm going to roll an odd number? Makes it really, really freaking unlikely, doesn't it? Because it's a 4. It's an even number. So those are dependent. Am I more or less likely to take 2 AP classes if I know that I'm taking at least 1? Does taking, let me rephrase it the other way, does the fact that I know I'm in at least 1 class make me more or less likely to be in 2?
Yeah.
Yes, it does. If you look at the population of people that are in at least 1 AP class, what percentage of those are in another one?
Big percent.
I don't take the AP classes, so I can
But I think like there's a higher proportion.
We're not talking about Kayla.
I know, I'm just saying. It's like, what if it's not everybody?
What percent of people in this school do you think take 2 AP classes?
90%.
90% of students?
Of kids that take 1 AP class.
No, okay, that's a separate question. That's the second field. So, what percent of students in this school, everyone included, take 2 AP classes?
Like it's
No.
Okay. 30? Is that fair-ish? Alright, now, take all the people that don't take any AP classes and throw them out. 82?
Probably like
75.
Does it change the answer? That's all I care about.
Yes.
It does, right? Kayla, does that make sense?
Yeah, but I still argue with it.
You can argue all you want.
Yeah, I'll argue. I can argue.
We can take the points off.
No, if I explain it, because
Let's hear it. Let's hear your explanation then.
I don't think if I'm like really good at one AP class and that's the only class I'm going to take, but if I'm really good at stats and not good at anything else, I'm not going to take 2 AP classes.
So you can't look at one person though. You have to look at the whole thing.
Okay, so you see it as a whole.
Like you, specifically you, that might not be truthful, but as a whole,
Okay.
does that make sense?
Yeah.
It's not always about you.
It's fine.
I don't know
I
if this
don't
is,
hear you. What are you?
I don't know if this is the right way of looking at it, but I kind of flip it around. It's like if you're not taking the one AP class, you're a lot less likely to be taking 2. It's kind of how I look at it.
Yeah, that's a good way to say that one. If you're not taking it, say it again.
If you're not taking that one AP class, then you're a lot less likely to be taking 2.
Does that help anybody? The rephrasing of it? Just a different way to say it. Alright. So those are dependent, for sure. So a similar thing would be like owning 2 houses and owning 1 house. Are you more likely to own 2 houses if we know you own 1?
Yes.
Yeah, right? So that's the same idea. Yeah. You being in AP Stats second hour and you being in gym second hour, independent or dependent? Dependent. Does knowing that you're in gym second hour change the probability that you're in stats second hour? Yeah. No, there's not. You being male and you being female, with no chromosomes, no X's and Y's are allowed to be said right now. If I know that you're female, does that change the probability that you're male?
Yes.
Yeah. So dependent or independent? Dependent. We're going to just leave that where it is right now and move on. Alright, check out your other packet.
Exactly where you're going.
Oh no.
So, you're going to be asked most likely on, at some point, whether it's on my test or like a multiple choice in the AP test, to define what probability is. So it's how frequently something occurs over the long run. Gotta do between 0 and 1, because 0 is like it never happens, 1 is it always happens. You see this notation here. So you got like the P. So P of heads would be 0.5. That means the probability of flipping a coin and getting heads is 0.5. That's just like a parentheses notation. So the probability of Tuesday coming after Monday is 1. Always happens. Probability of snowing while it's 9 degrees is 0. Never happens. This long run is a hugely important word. So if I flip 100 coins, does that mean that I'm going to get 50 heads and 50 tails? It doesn't. This is a very common AP question, actually. I flip 100 coins, 80 come up tails. How many tails would you expect in the next 100 flips? Take a second and think about this and answer. I'm trying to put it so you can read it, sorry. Are you trying to communicate with me? Okay.
Smoke signals.
How many think it's 20? How many think it's 50? How many didn't offer an opinion?
I just was trying to get that.
Oh, right. So, some people will try to tell me, well, that's 200 total flips, and I know that I'm supposed to get 100 tails. So if I had 80 already, I need 20 more. Don't write that down. That's terrible thinking. Does the coin know that it's supposed to balance itself out by the time it gets to 200? Is there any reason it would know that? Does this information change anything? It doesn't. If I flip 100 coins, I'd expect to get 50 tails. It doesn't mean I will, but that's like the most likely thing, knowing that I got 80 in the first 100 doesn't change a thing.
What's the answer?
Because it doesn't matter what happened before. Like, if I flip 100, I should not expect you to.
No,
I mean, I will.
I just want to try.
Okay. Random, unpredictable in the short term. That's another word you probably have to define. I don't know what's going to happen the next day, but I know over the long run what's going to happen. So this is casinos. So if I go play blackjack over the long run, what's going to happen? I'm gonna lose everything I have if I keep playing. But in the short run, like if I just go play for an hour, could I win? Yes. So that's why casinos exist. People think they can win, but they get enough people in there playing the casinos. That's why casinos are enormous. Over the long run, the house is going to win. The probabilities always catch up to you. Try to answer these two questions on sample space. Those are two different questions. They'll try to, like, to me, this is kind of a tricky, we're trying to gotcha type of question, but I've seen it out there, so. Sample space, just all the possibilities. So if I flip three, you flip 3 coins, and I say, how many heads did you get? What are your possible answers? I heard 1, 2, and 3, but there's different. Yeah, so 0, 1, 2, and 3. That's not here, the 0. And then you put them in those little braces. That's to show, like, that's a sample space. This is a different question, though. You flip 2 coins, and I'm saying, hey, what was the outcome? What are your possibilities? If I said, hey, what was the outcome? You flip 2 coins, what happens? You say, like, 1.
No heads.
Right, so
Coin 1 is heads, coin 2 is tails, coin 2 is heads, coin 1 is whatever it is.
how's this?
Yeah.
Yeah. So those are 2 different outcomes. Those are 2 different questions. Just make sure you, like, read through the question carefully. Does that make sense, the difference between those?
Couldn't you figure that one out just doing 2 squared? 2 times.
Figure what out?
Like the second one.
That answers the question, how many possibilities are there?
Right.
This is, what is the sample space? So what are, to list all of the possible outcomes.
You actually have to list.
So I have to list them, so that's why, did you see me list them
Yeah.
there?
Now
Is your concussion acting up again?
brain's still a little skinny.
Alright. We're going to do a tree diagram. This is a pretty powerful thing because it answers a lot of questions that you might get stuck on. You can kind of jump back to, okay, make a tree diagram. I'm going to do one, make the table. You're going to do one on the next page. I have a coil that lands head 60% of the time. I'm just going to do the tree and see like what happens. So, on my first flip, I got 2 possibilities. 60% chance that I get heads. There's a 40% chance that I get tails. That's one flip. And then from either of those 2 flips, I'm going to flip it again with the same type of thing. So I make another branch off of both of the 2 branches that are already there. And then what you do is multiply the branches together. So like this top branch is heads then heads. Probability of getting heads then becomes 0.6 times 0.6 because that's the 2 numbers that I took like along the heads path. And that would be 0.36. So what's the probability of getting, oops, let's say heads. Heads tails? Well, that's the 0.6 and then the 0.4. That's 0.24. You guys see what I'm doing? Probability of tails heads. 0.4 times 0.6. It's also 0.24. The tails is 0.4, double 0.4, so 0.16. And then a probability table, I want to put the number of heads on top. And you can make a table any you want. I'm just saying in this case, we're going to put the number of heads on top, the probability on the bottom. What's my sample space? What are the possible outcomes for number of heads? 0, 1, and 2. And then you just put the probability of each one of those below that. So 0 heads means I got tails, tails, right? What's the probability of tails, tails? 0.16. 1 head happens twice, so it can go heads, tails, or tails, heads. So you add those two up. That would be 0.48. And then 2 heads was 0.36. What should all of these add up to on the bottom? They have to add up to 1 because that's going to show you 100% of the data. Questions on what I'm doing there? Alright, on the next page I want you to do it. So I'm flipping it 3 times, and the probability of heads is 0.7. So you're going to have a bigger tree. You're going to have 2, and then each of those have 2, and then each of those have 2. So how many different things will be in the end? I'd like a little more specific answer than that. First flip, 2 options, right? Then there's 2 of each of those, so now what are we at? 4. And then each of those 4, you go 2 from each of those, so now what are we at? Just do it. Yeah, do it. It's easier than that. How many possibilities are there for each flip? Let me try to process what you said. I'm trying to help you understand this, and you told me to shush. Is that what was going on? There's 2 possibilities on each flip. How many flips are there? 3. So you do 2 to the 3rd power. What's 2 to the 3rd power? If you say 6, I'm going to push you. If you say 16, I'm going to kick you. It's 8. Very concerned about the future of this class. And then make that table at the bottom where you put the probability of number of heads.
Like yours goes to the right and mine goes down.
Oh yeah, some people like to do these like vertically. That's totally fine. Like if you want to start at the top and be like, okay, heads or tails from there. Yeah. This is like what fits my brain, but that doesn't mean it's what fits yours. Yeah. So how many different possibilities are there? 8. should be your tree diagram. How many? Either have it done or like you're on the way and not done yet, but you have what I have. How many understand what this is supposed to do? Is what basically what I'm trying to figure out. Other questions on what I'm doing or where I'm getting stuff from or anything? And then once you're done with that, make the thing at the bottom, so number of heads, the probability for each one. Everybody else did their tree vertically? So that's that. How do you interchange? Like this Which ones do you have to add up to see what you're saying? That's how I remember it. So, what are the possible results for number of heads?
0, 1, 2, 3.
0, 1, 2, or 3. 0 would be tails, tails, tails. That just happens the one time, so you can just write it down. You get one head 3 different times. That's 0.063 each time. So that'd be 0.189. So you're adding up the 3 times that you get one head. For the 2, we're adding up the 3 times we get 2 heads, so it's 0.147. There's 3 of those. So that's 0.441. And then 3 is 0.34. Questions on that anywhere? It's a pretty important thing. Like, we'll use that the whole chapter. Good? Alright, there's no homework or anything. We'll just keep going tomorrow. And you can start your con if you want. You got some time, but there's quite a few. 15? 15. That's 2 weeks.
Okay.
When is it?
Are these the 7 ones?
Next Friday. What?
Are these the 7 ones or the 4 ones?
I don't know.
They're the 7
The first 4, I think, are really simple. I think. And then it gets to medium. I don't think anything's too bad.
So it's like 7.
I don't know. I don't do it. I just tell you to do it.
I feel like